this is Miss Sebastian, and we're going to be looking at functions today. So the first problem that we're going to look at is finding the next three terms in this sequence. So you have 30, 24, 18, and 12. So each time, going from 30 to 24, we're decreasing, so that means subtract, and we're subtracting 6. From 24 to 18, we're decreasing again by 6. 18 to 12, we're decreasing by 6. And then we're going to do it for the next three terms. So decrease again by 6. So 12 minus 6 gives me 6. Decrease again by 6. 6 minus 6 is 0. And then one more time. We're going to decrease again by 6. 0 minus 6 is negative 6. So the next three terms in this sequence are 6, 0, and negative 6. Write a rule for the sequence. So the first thing we've got to do is figure out what is happening here. From 3 to 6, we're adding 3. 6 to 12, we're adding 6. Because this isn't a consistent number, it's not a arithmetic sequence, it's a geometric sequence. So if we're doing 3 plus 3, that also means 3 times 2. 6 times 2 gives me 12. 12 times 2 gives me 24. So on this one, the 3 is our first term in the sequence. So our first term is 3. Second term is 6. Third term is 12. Fourth term is 24, and so on. For a geometric sequence, we always have our formula to fit these into, and it's a to the n equals a times the multiple, and okay, so the multiple raised to a power for the number of the position it's in. So our first term is a. So a is the first term. That first term is 3. The multiple is r. That's the multiple. And that means, what are we multiplying by? We're multiplying by 2 raised to the n minus 1. The n means what number position is it in. So we can test this by saying, okay, 3 times, and I want to test it for the fourth position here. 2 to the 4 minus 1. Well, the 4 minus 1 is 3. So 2 to the third, 2 times 2 is 4, times 2 is 8. So 3 times 8, that is 24. So that works out. So our rule for this sequence is 3, which is our first term, times 2, which is what we're multiplying by, raised to the n minus 1. And n minus 1 is what you will always have as that exponent. So the first term times the multiple. Find the first 4 terms of the sequence represented by the expression. So n is always the number of the position. So I'm going to say the first position, I'm going to plug it in. 2 plugged it into where the n is, minus 4. So that's 2 minus 4. That gives me negative 2. So the first term is negative 2. I'm going to put it up here. And then we're going to look for our second term. Well, in the n spot this time, I'm going to plug in a 2. So 2 times times 2 minus 4. So 2 times 2 is 4. 4 minus 4 is 0. So I've got 2 terms. Now I'm going to look for the third one. 2, there's a 3, minus 4. So 2 times 3 is 6. Minus 4 is 2. And for the last term, I'm going to plug that 4 in where I see the n. So 2 times 4 is 8. Minus 4 is 4. So those are the first 4 terms in this sequence. The graph below shows your speed at different times while riding a bicycle. For how many minutes did your speed decrease? And decrease means going down. D is for down. So when I look at this graph, I see first it goes up, and then here it changes all the way to here. It's going down there, and then it's constant after that. So I'm looking for the part where it goes down. And the x values that it goes down for are from the red line to the red line, which is 3 to 7. So if I subtract 7 minus 3, I do get 4, and that is minutes. So for 4 minutes, your speed is decreasing. The graph shows the amount of gas in the tank of Sharon's car during a trip to her mom's house. How many gallons were in her tank right before she bought gas? So I'm looking at this graph and I see it looks like she started with 12 gallons up here. If we follow the line, she's trucking along and her gas tank's getting emptier and emptier and emptier and emptier. And it looks like she stops here. And then her gas tank gets full again. Okay, so it looks like right here is where she stopped to get gas. So if we look at that, it is almost at 7:30. So we could say about 7:30 she stopped to get gas. And then you can kind of see, if you look to the left, how many gallons of gas she had before she filled up. You can see a lot of things if you look at that graph and kind of see what it's telling you. Create a table of values for y equals 2x minus 3. So what we're going to do is we're going to take the x values given. The first one is negative 5. We're going to plug it in where we see x because that's what it says x is. So all I'm doing is plugging it in right there and rewriting it. So we're looking for our y value. So I'm going to start simplifying. 2 times negative 5 is negative 10. Negative 10 minus 3 is the same as negative 10 plus negative 3. So that is negative 13. I'm going to do the same for the next one. Y equals 2 times my x value, which is negative 8, minus 3. So 2 times negative 8 is negative 16, minus 3, or plus negative 3. That gives me negative 19. Now I'm going to do negative 7. y equals 2x minus 3. I'm going to plug in negative 7. So I need to multiply 2 times negative 7. That's negative 14 minus 3, or plus negative 3. And that does give me negative 17. Now 0, I like 0 because it's one of the easiest ones. Because when you plug in 0 and try to multiply by it, it's just 0. So 2 times 0 is 0 minus 3. Well, that's just negative 3. And then last we have 1. Y equals 2 times 1 minus 3. So 2 minus 3, or plus a negative 3, is negative 1. And that is it. All you have to do is plug them in. A gas station charges $1.39 per gallon of gas. Use function notation to describe the relationship between the total cost and the number of gallons purchased, which is G. So the total cost, when I think of total, I think of my equal sign. So I'm going to put my total cost, which is the cost per gallon, okay, or the cost per number of gallons, equals, and then we know we're going to purchase G gallons. That could be 10 gallons, that could be 4,000 gallons, it could be 1 gallon. But how much does it cost for each gallon of gas? Well, when I think of a gallon of gas, each gallon is $1.39. So I'm going to multiply the number of gallons by $1.39. So if I got 2 gallons, that would be $2.78. If I got 10 gallons, that'd be 10 times $1.39, or $13.90. So that cost per gallon in function notation, that just means with those parentheses there, is $1.39 times the number of gallons you are getting. Use the function rule f of x equals 2x minus 1 and find the output for f of 2.5. So all that means is you're going to plug in that 2.5 where you see the x. So we're going to say f of 2.5 equals 2 times 2.5 minus 1. So 2 times 2.5 is 5 minus 1. 5 minus 1 is 4. And I'm done. That's all you have to do there. Identify the sequence as arithmetic, geometric, or neither, and tell me why. So I'm going to look here and I say, oh, we could subtract here and we could subtract 1.2. But then we subtract 0.4. So that doesn't work. It cannot be arithmetic there. But I could also say, okay, that's 18 and 6. That's dividing by 3. Ooh, 0.6 to 0.2. Ooh, that's dividing by 3. Because we are dividing by the same thing each time, that is geometric. Because it has a common ratio. A common ratio.